In today's video, we will be talking about magnets. After watching this video, you should be able to understand what a magnet is, what materials are considered magnetic, and how magnetism occurs. So let's get right into it. What is a magnet? Well, a magnet is basically a material that has the ability to exert a force on magnets or other magnetic materials. So I'm sure you guys have all played with magnets before at some point in your life. If you stick a magnet on a piece of wood, it does nothing. But if you stick it next to, say, like an iron nail, it attracts the nail and it's pulled towards it. Okay, so a magnet basically is just something that has the ability to exert forces on either another magnet or something that can be considered a magnetic material. So you may ask yourself, well, what type of materials are magnetic? Believe it or not, there actually aren't that many things that are found in nature that actually are magnetic. Three elements that are magnetic would be iron, nickel, and cobalt. These guys are all strongly attracted to magnets, and they are actually called ferromagnetic. And basically what it is they can be induced to have magnetic properties. So you may say to yourself, well, what the heck causes magnetism in the first place? There still is some debate on basically how magnetism exactly occurs. Like, it's not completely understood 100%, but from our understanding thus far, basically it is the movement, well, actually there's two ways. There's a movement of charge, which is called an electromagnet. So current in like a electrical wire causes magnetism. The second is, and maybe something that would be more you've seen before, be just like a refrigerator magnet. The alignment of the electrons in the refrigerator magnet, they all spin in a direction that creates magnetism, and that's called a permanent magnet. So you may say, well, what the heck is electron alignment? Basically, magnetic properties are exhibited by charges in motion. As we all know, electrons are spinning around the nucleus of an atom, and they're all in motion. Well, you may then ask yourself, well, why isn't everything magnetic? Because this is all happening in every type of object. Each individual electron in any object, a wood table, a magnet, a piece of chalk, all have electrons that produce a very weak magnetic field, something you wouldn't even experience on its own. But when those magnetic fields all start to work in the same direction or same orientation, then you get a strong magnet. So that's how a magnet is different than, say, like a piece of wood. The magnet's electrons are all working together in the same direction to cause the magnet to create a magnetic field, and this is called magnetic domains. So it's basically the electrons are what actually creates magnetism in a magnet, along with actually a current carrying wire. The electrons in the current carrying wire are what create magnetism. So here's a picture that might kind of help explain that a little bit. Magnets, this is like a non-magnetic material. You'll see the electrons aren't working together, they're all just going in whatever direction. Okay. Here you can see that this is magnetized because the electrons are all working primarily in the same direction. They're aligned, and so that produces a magnetic field. This is a ferromagnetic material, and basically what that means is that this material has the ability to become aligned. Right now it's not. The randomness of it all cancels it out. But if you were to put a magnet near this, these arrows would start to align, like in this picture here, and then you would have magnetic properties. Okay. Now with a magnet, just so you guys know, heating it or hitting it, like dropping magnets or heating it up, will I say kill the magnetic properties of the magnet. It does not so much that it dies per se, but it's not magnetic anymore. So if you continually throw a magnet against the wall, eventually it will not become magnetic anymore. Permanent magnets do have a north and south pole. They are called a dipole, and this includes bar magnets, refrigerator magnets, and horseshoe magnets. Now what's interesting is, as far as we know in nature, no magnet exists where, like, if this is a bar magnet and here's my north and south pole, if I were to slice this thing in half, you would now have two magnets with a north and a south pole. oddly enough. And you can keep slicing it in half and half and half, and you always have what's called a dipole, where you have a north and a south. You never have just a north or just a south. At least we haven't found it yet in nature. Maybe somewhere out there in the universe such a thing exists. But we always find magnets with a north and south pole, no matter how small it really is. So just like in electricity, like poles repel each other. So two north poles, if you put them near each other, they will repel each other, and opposite poles attract each other. So north and south attract each other. And that's just called the law of magnetic poles. I don't think that's anything super unusual, if you will, because we've done all this stuff with electricity, and we're pretty familiar with that. So law of magnetic poles, basically likes repel, opposites attract. Now, if you induce magnetism, basically what that means is a neutral but ferromagnetic material is brought near a permanent magnet. And when it's touched to this magnet, like these iron nails are, their electrons align to become magnetic themselves. And so you can basically string a bunch of paper clips or nails together and they all become magnetic. Now, if you take the magnet away, they'll stay magnetic for a little bit, but then their magnetism wears off relatively quickly. So that induced magnetism only lasts for as long as basically that the permanent magnet is there. And that's just induced magnetism. Now the Earth, as you may or may not know, if you use a compass, basically a compass relies on the Earth's magnetic field to guide you in terms of what direction you're going. And the Earth's magnetic field is created by the rotation of the iron-nickel core that is found towards the center of the Earth. The outer core is made up of liquid iron and nickel. The north end of a magnet compass, or a magnetic compass, will point towards the North Pole. So that's how people can tell directions using a compass, as they rely on the Earth's magnetic field. So opposites attract and likes repel. What is the orientation of the Earth's core? And it's kind of interesting to think about. The Earth's core, basically, south is at the North Pole and north is at the South Pole. And if you think about that for a bit, that makes sense, because a compass will point north, and the north would be attracted to the south of the Earth's magnetic field. If this is really confusing to you, spend some time thinking about it, and I think it'll make sense. It's kind of an odd phenomenon that I never really thought about until I was making these notes. But the south is actually the north in the Earth's magnetic field, oddly enough. So there's this thing called flux lines, and it's just basically a fancy term for basically lines that show the direction of a magnetic field. It's kind of like an electric field when we were dealing with static electricities. With magnetic fields, they too have lines, and they're called flux lines. The more lines that exist around a magnet, or the more densely packed that those lines are, the stronger the field. And the lines will go from the North Pole to the South Pole. And I'll show you some pictures of that right now. So here's some flux lines for a bar magnet and a horseshoe magnet. Notice from the North Pole, which is over here, the lines go and they will travel to the South Pole. And these are just called flux lines. Okay? And the more of them that there are, the stronger the magnet. Here are flux lines for a bar magnet, again going from the North to the South Pole. I'm sorry, that was a horseshoe magnet, not a bar magnet. And again, opposite poles attract and likes repel, and so this is kind of something cool you can do with two bar magnets. Bring a north and a south near each other and put some iron filings on top of it, like on a glass plate. And you can actually see the magnetic field lines being created by the iron filings. So kind of interesting to look at. And again, the more of the lines that exist, the stronger the magnet. All right, that takes care of today's video on magnets. I will see you guys next time.